Hello and welcome to How to Do Punnett Squares. So let's talk about some definitions right now. So the first words you need to know for this to make any sense at all are, um, oh gosh, blanking, are dominant and recessive. So if you have a trait that covers up another one, that is the dominant trait. If you have a trait that gets covered up when they're both available, that's recessive. So a dominant trait, you're going to use a big letter. Like let's just use A for our example. You're going to use big A for your dominant trait and little a for your recessive trait. So then an individual has three choices. They can, because they're going to have two copies of this gene. They can have two big A's, they can have one of each, or they can have two little A's. So for any trait, you've got three choices. You can be big A, which is homozygous dominant. You can be big A, which is heterozygous. Or you can be little a, which is homozygous recessive. So homozygous dominant as the big letters, which are the traits that cover up the other. Heterozygous has one of each, and homozygous recessive has two small letters. Okay, so these are the way you're going to set up your traits in to do Punnett squares. Okay, so you've got to first know about your trait. Is your trait completely dominant, where one version of the trait completely covers the other? Or is it incompletely dominant, where the heterozygous, remember heterozygous is the big letter, little letter, the heterozygous has an in-between trait. So in incomplete dominance, the heterozygous is in between. So let me use cows as an example. You guys, some of you show cattle, some of you don't. But let's talk about Angus cattle. Angus cattle can be black Angus or they can be red Angus. Turns out the black Angus gene is completely dominant to the red gene. So in Angus cattle, if you are big A, you are black. Well, the cow is black. If you're little a, you're red. If you're big A, you're heterozygous. That means you have the dominant trait, so you are black. So the Angus cattle can be homozygous dominant, which is black, heterozygous, which is also black, or homozygous recessive, which is red. Okay. For incomplete dominance, you have an in-between for your heterozygous. So let's talk about shorthorn cows. Now, I don't know how many of you guys know what shorthorn cattle are. That's the kind I grew up with, the kind that I had. In shorthorn cattle, the dominant trait is red, the recessive trait is white, and the heterozygous trait is roan, which means red and white spotted. Okay, so big A, or whatever letters you use, and you can use whatever letters you want. You just want to be able to tell your big ones from your small ones, is the dominant trait. Little a is recessive, so this would be red, this would be white. Heterozygous is the in-between, so that is your roan, that is your spotted cow. All right. So we have a few examples now that we're going to do. So a Punnett square is a 2x2 box that is going to look like this. And you're going to put one parent's genes on top of the box and one parent's genes to the side of the box. So let's say, just like it says in your packet, that in Angus cattle, remember, black is dominant to red. So, and we use H for hair. So big H is black. Heterozygous is black. And little h is red. So these are our choices up here, right? Black homozygous, black heterozygous, and red homozygous. So what if we cross a homozygous dominant cow with a homozygous recessive bull? So we have a big H cow and a little h bull. We're going to put the H's for one parent on the side of the punnett square and the ones for the other parent on the top. Doesn't matter which is which, it all works out the same. So let's just put our big H's on the top and our little h's on the side. Okay? Now, these boxes represent possible offspring. So this doesn't mean that they're going to have 4 babies, because cows usually have 1, occasionally 2. These means these 4 are the options that those babies can have, depending on, during meiosis, which letter gets into the egg and which letter gets into the sperm. Okay? So one gene comes down from the top and one gene comes over from the side. So this box is going to have a big H from the top, a little h from the bottom. It's going to be big H, little h. Okay? Next one is also going to be big H, little h. Big H comes down from the top. Little h comes over from the side. It's going to turn out all 4 of these are going to be big H, little h. So the first thing you do is you figure out what the parents are. Homozygous dominant is big H. Homozygous recessive is little h, little h. Step 2 is you put the parents around your square. Okay. Step 3 is you move your genes. You come up with your offspring. Okay. So in this case, the next step is you want to figure out the genotypic ratio. What genes are possible for the babies? This one's big H, little h. 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 So they are all big H, little h. Okay? So your genotypic ratio is going to be what options do you have? And in this case, all of your options are heterozygous. Phenotype, geno means what genes do they have? Pheno means what do they look like pheno, photograph, both start with PH. In this case, big H, little h tells you that it's black, right? So all of the calves, all the possible calves are going to be black. Okay, so your genotypic ratio is all big H, little h. Your phenotypic ratio is all black. All right. So now this time, let's do another square. And this time let's cross a homozygous recessive cow with a heterozygous bull. I think that's what I did. Let me double check. Okay, just a second here. Pulling up the sheet here, so I'm giving you the same ones that you have. Okay, yeah, so red-haired cow, homozygous recessive, and a heterozygous bull. Okay, so we have homozygous recessive is little h, and heterozygous is big H, little h. So just like we did before, we're going to put one parent on the side and one parent on the top. And again, it doesn't matter which parent goes where because it's going to cross the same. We put them together. The big H comes over. The little h comes down. On the bottom here, little h comes over and little h goes down. And then on the other side, big H, little h, little h, little h. Okay? So this Punnett square has some differences. Two big H, little h's, two little h's. So our genotypic ratio is 2 to 2. There are two big H, little h's and two little h's. Okay? Our phenotypic ratio, the big H, little h's are going to have black hair. The little h's are going to have red hair. So that's also going to be 2 to 2. All right? So our ratios match. They don't always. All right? So that is our second example. So hopefully you're filling this in, these examples, so that when you have your assignment, after you watch this video, you'll be able to do this on your own. All right? So our next example, we're going to cross a heterozygous cow and a heterozygous bull. So what does that mean? The one parent is going to be big H, little h, and the other parent is going to be big H, little h. So it's going to look like this. Well, X just means cross. Bull, cow, could be in either order. And so one goes on the side, one goes on the top. All right, just like this. So now we're going to do the crosses. Top left is going to be big H, big H. Bottom left, big H, little h. Top right, big H, little h. Bottom right, little h, little h. So when we fill it in, we've got this, don't we? Genotypic ratio. Okay, so genes the cows have. This one, this possible calf, is big H, big H. Both of these are big H, little h. And this one's little h, little h. So we have a 1 to 2 to 1 possible ratio of genotypes. Now, this is going to be the first one where phenotype is different. What color is this cow? It is a black cow. This one's black, heterozygous because the dominant trait covers. This one's black, so 3 of them are black. Little h, though, that's red. So the phenotypic ratio is 3 to 1. All right? So let's go ahead and go to a different trait. So we've done 3 examples with the cows. Let's look at goats. In goats, many goats, if you're probably less familiar with goats, but many goats have a beard. So if this is your goat, here's a goat's little mouth, there's a little eye, its floppy ears. So there's my goat, kind of sad, huh? Many goats have a beard. And unlike in people, where this is generally a male trait, in goats, both males and females can have beards. There's no difference gender-wise. So a bearded goat is, and we'll go with B for beard, is dominant to a beardless goat, little b. So the bearded goats can be big B, or the heterozygous, of course, and the beardless are little b. So notice, I'm using different letters now. Using different letters, but it's going to work exactly the same. Okay? So let's cross a heterozygous goat. What does heterozygous mean? One of each. Big B, little b. With a homozygous bearded goat. Big B. So our parents are going to look like that. Homozygous bearded on the top, heterozygous on the side in this case. So as we cross those, our top 2 goats are big B, and our bottom 2 goats are big B, little b. So genotype we have 2 homozygous dominant, 2 heterozygous, a 2-to-2 ratio. Phenotype, all 4 of these possible goats, they all have beards. So all bearded. All right. So we'll do one more goat example, and then we're going to move on to an incomplete dominance problem. So number 5 there says, let's cross 2 heterozygous bearded goats. So I'm going to draw my Punnett square. I'm going to figure out that heterozygous means 1 of each. So I'm going to put my parents, 1 on the side, 1 on the top, right? And then I'm going to do my crosses. Top left is big B, bottom left is big little, top right is big little, lower right is little, okay? So our genotypic ratio, and you're going to need to write these in, is 1 big B, 2 heterozygous, and 1 little b. So it's 1 to 2 to 1, right? Our phenotypic ratio, what do they look like? Beard, 3. No beard, 1. 3 to 1. Notice that is the same as we had what was that? That was the same as we had with the 2 heterozygous cows. Heterozygous complete dominants are always going to give you a 1 to 2 to 1 ratio, turns out. Kind of groovy, huh? All right, last thing. We want to look at incomplete dominance. So imagine a horse, if you will, and this is the horse's nose. We're going to draw 3 horses. So this is not the whole horse, it's just the horse's nose, right? You could have no markings. Just a solid colored horse, black, brown, green, whatever. You could have a blaze, where the horse has a big old blaze on its nose, big old stripe of white, okay? The heterozygous horse has a star. It's in between. Instead of having a blaze, instead of having no mark, it's just got a little mark on the forehead. Now, you know, and I know, that horses can be a little more varied than this. There's more than one gene that controls facial markings. But there is one gene that says blaze, no blaze, or star, okay? So we could do F's here for face. Oops. Big F is blaze. Little f is no mark. And star is heterozygous. So let's cross a horse with a star. It's going to be big F, little f. And a horse with no facial markings, little f. So we have a big F, little f, and 2 little f's, okay? All right. So then we'll fill them in. Big F, little f, big F, little f, and 2 little f, okay? So our top 2 are heterozygous, and I kind of messed that one up there. And our bottom 2 are homozygous recessive, okay? So genotypic ratio, we've got 2 heterozygous on the top. We've got 2 homozygous recessive on the bottom. Phenotypic ratio, this is going to be a little different because there are 3 phenotypes now, not 2. So our genotypic and phenotypic ratio and incomplete dominance, they're always going to be the same. In this case, we've got 2 stars and 2 no marks, right? Now, let's do one last one, and this is my last piece of paper, so I'm going to do it on the same page. All right. So we're going to cross two horses with stars. Remember, stars are heterozygous. So big F, little f on the side, big F, little f on the top. Two big F's on the top left. One of each on the bottom left. One of each on the top right. And two little f's on the bottom right. Yep. Our genotypic ratio is 1 to 2 to 1. Our phenotypic ratio is 1 to 2 to 1. Okay. Now, hopefully, with these example problems, and this is not an assignment, this was to fill in so that you have examples to work with. Hopefully, with these, you will be able to finish your part 1 assignment. Now, for 7th grade, these are the two types of Punnett squares you're going to do. For 9th grade, we're going to get into some more complex ones in part 2, which will be tomorrow's assignment. All right. So thank you and have a good day.